All right, so today we're going to learn about Pythagoras' theorem. And as you can see, Pythagoras was a Greek mathematician and philosopher. And so our standard today is looking at the Pythagorean theorem. So we're going to provide geometric proof. We're going to prove the Pythagorean theorem using this theorem to find the missing sides or lengths of right triangles. And we're going to throw in some real life problems in there. So people do use this in real life, and I'll show you how. Okay, so Pythagoras' theorem says that when you have a right triangle, side C, so let's look at this triangle here. Side C is the one that is opposite of the square. Okay, so in your notes, I want you guys to draw a right triangle. If there's a triangle on a paper, you'll know it's a right triangle because it will always have this box in the corner. That tells me that this is a 90-degree angle. Okay? So the side directly across that 90 degrees angle is called the hypotenuse. And this was part of your notes, which you should have written down, but I really want to bring that home to you. It's usually on a diagonal. Okay? So your hypotenuse is always going to be side C. Always. A and B are interchangeable. It doesn't matter. This could be A, this could be B. I like to get in the habit of calling my smaller side A and my middle side B. You don't have to do that, but that's what I'm going to do, and that's the practice that I like to get into when I solve these problems. Okay? So Pythagoras said that if you have a triangle and you know the length of the sides, you'll know if you have a right triangle with a 90-degree angle, if his theorem of a squared plus b squared is equal to c squared. Okay, that's what he said. So based on the lengths of the sides, do you need to stand up? Sit up. Based on the lengths of the sides, you'll know if it's a right triangle. Okay, so this is important. I hope you guys wrote this down. This is a simplified version of the notes that you took down. But the more you write it, the more it stays in your head, and the more you're able to recall it when it comes to test time. Now, take out your note card that I had you guys write. Because if you notice on your note card, you already have information about Pythagoras, the Pythagorean theorem. Yes. Alright, so again, here's that information. So this is technically the third time that you've written down this information. Here's a right triangle. There's my square. The angle opposite that is going to be your hypotenuse. So this is going to be also side C. The theorem states that a squared plus b squared is equal to c squared. Okay, so now we're going to prove that theorem. So go back to your worksheet, and we're going to look at triangle 1. This is a triangle. It gives us the lengths of our side. So it wants us to find the missing lengths. So what is side A? What does it measure? Based on that information. It measures 3. So I'm going to say 3 squared. What does side B measure? 4 squared. Devin, can you open the door, please? And what does side C measure? What's it say? We don't know. So it's going to be c squared. Remember, we're using the Pythagorean theorem, a squared plus b squared is equal to c squared. So we're taking the information we know and we're substituting it. Okay? So right now, all I know is side A and side B. So what is 3 squared?
9.
And what is 4 squared? And that's going to equal c squared. What is 9 plus 16? 25. So I'm going to rewrite this as 25 is equal to c squared. Okay, so now I don't want to know what c squared is. What do I really want to know? I want to know what c is equal to. What does c equal? So if c squared is 25, what do I need to do here? Kind of. I need to take the root. So I'm going to put a root over this. When I take the square root of c squared, my roots cancel. That leaves me with just c. Do I know what the square root of 25 is? So c is equal to 5. Pretty simple, right? Yeah? Okay, so once again, up here, a squared plus b squared is equal to c squared. What's my a? 7 squared. What's my b? And what's my c? C squared, because we don't know, right? So when I had you guys do your squares, how far did I have you write up your squares till? 20. So are you going to have 24 squared on your note card? So, but you do have access to calculators, right? So we're going to look at this. What is 7 squared?
49.
Right? I don't know what 24 squared is, but I can say 24 squared is 576. Then I can add 49 to 576, right? And that'll give me my answer. I get 625 is equal to c squared. Now, I have to take my square. So I'm going to do square root of c squared. And remember that balance still has to remain. So whatever I do to this side, I have to do to this side. Square root of 625. The square root and the exponent cancel. So what does c equal? Huh? 25? So if I take the square root, using my calculator right here, shift square root 25. So c is equal to 25. Understand? Now that's also going to work in the event. So let's look at number 13. This time I have a triangle, right? So what is my c going to be?
7.
Right, so I know c, I'm going to write this a squared plus b squared is c squared. I know that this is c, so this is a shorter side, right? So I'm going to call it a. Do I know what b is equal to?
No.
So b is now what I'm looking for. And it's still going to work. What is my a? 8. So I'm going to say 8 squared plus b squared, because I don't know what b is equal to what squared? 17 squared, right? Because in place of c, I know it's 17 because it is the hypotenuse or the side directly across from this right triangle, from the right angle. Okay, can I still solve this? So what is 8 squared? So I have 64 plus b squared is equal to, what is 17 squared? It's on your card. 289, right? So this time I have to add an extra step. I need to move this 64 over here, right? So I'm still keeping, remember that scale, that balance? I'm going to draw that line just so that I know what I do here, I have to do on that side of that line, okay? So how do I move this positive 64? Angel? I'm going to add the opposite. So the opposite is negative 64, and I'm going to subtract that from both sides, right? So that's going to give me b squared is equal to the difference between 289 and 64, which is what? 225, right? So in order, I don't want to know what b squared is. I want to know what b is. So I'm going to take the root on both sides. My roots cancel, right? So what is b equal to? Whoops. B is equal to 15. Does that make sense? Okay, so you could totally use your calculator and your card, but I still want to see the work. Okay, I still want you to write out the Pythagoras' theorem. I still want you to substitute. I want you to tell me what their squares are, and I want to see that you're taking the root. I want to see every step that you take to solve these problems. Now, if you're writing big, I can recommend that you take out a separate sheet of paper and show your work on that. You're only doing the front side. Tomorrow, we'll do the back side. So do not lose your paper and do not turn it in tomorrow. This whole sheet will be due on Thursday. Today, you are just doing this. Here's a hint. These are the answers. Okay? But like I said, what do I need to see? This is just to make sure you're doing it right. So if you get an answer that's different, you need to go back to your problem and figure out where you went wrong. Understand? Okay, so when you turn it in tomorrow, there should be 0 errors. You should have checked your answers, and you should have the right work. Understand? Any questions? Fist of 5, I get this, I don't get this. All right, let's hit it. Start to work.